videos there.
Hi, good afternoon. My name is Paul Scott and welcome to today's webinar brought to you as part of the Innovation Showcase, the global competition for hardware-led social innovation. Just to talk a little bit about what we're going to do today, we'll have a presentation from Ryan Vinyard from Highway 1. He's the engineering lead over there. Really grateful that he could make the time to join us. Then we're going to go into a question and answer session. So if you've got any questions that you would like to know about prototyping or any feedback on the presentation, we can take the opportunity to do that either through the chat function on your screens. If you send us the questions that way, and then we can answer them verbally to you. Just to talk a little bit about who we are and what we're trying to do. So we sit in an organization called the American Society of Mechanical Engineers. We're a professional association and we have about 150,000 members in over 100 countries. As part of that platform, we're running a competition called the Innovation Showcase. It's a global competition for hardware-led social innovation, and we're running the competition in India, in the US, and in Kenya. We've just actually come off the event in India where we had 12 innovators from around the country and also outside of India, from Cambodia and Indonesia as well, and they were competing for a pool of $50,000 in seed funding as grants for prototyping, and then also a design and engineering review that they received from industry experts. So why are we doing this competition? Basically, we feel in the social and environmental innovation space there's not enough support in terms of design and engineering advice and assistance. So the level of funding, the level of mentorship is lacking, and what we're trying to do is to raise awareness of the importance of effective prototyping and the importance of actually taking products to market to solve social and environmental challenges. So over the 3 events in the 3 countries, we've got about $500,000 worth of prizes. Past participants who have been within our competition have raised venture money of over $1 million. We had about 300 applicants this year. We have 30 finalists, 10 in India, 10 in the US, and 10 in Kenya. And after the process is finished, we'll have 9 organizations that we've provided seed capital to in this design and engineering review. We're very excited because our event in Washington, D.C. is next Thursday, the 14th of May, and we've got some great innovations to showcase there. If you're interested in finding out more, you can go to thisishardware.org. Just to say as well, why are we focusing on hardware? It's complex, it's unique, it's different. You face different challenges if you're taking products to market in terms of supply chains, manufacturing, prototyping, and we just don't feel that there's the support out there. As a mechanical engineering society, we want to help provide that support. We also want to connect you with industry that can perhaps find markets for the products, and then also have good advice and assistance in terms of the process and journey of doing that. And so at ASME, we're particularly interested in this social innovation piece because we really do feel that engineers have a key role to play in advancing humankind. They've solved many of the challenges in the past, and there's a whole host of global challenges coming up that we think engineering has a really key role to play in. So what types of things do we think of when we think about hardware-led social innovation? So you can think of it in terms of a number of different buckets and areas. Social innovation is a very buzz term at the moment, but what does it actually mean? So we broke it up into these 8 areas. You know, perhaps it's energy-related, safety-related, water and sanitation, agriculture-related in terms of technologies for more efficient yields, health and nutrition. We're seeing a tremendous amount of activity and interest in sort of health tech, biotech, and wearables. And, you know, with the making movement and the accessibility of 3D printing and additive manufacturing, you know, the prototyping process is becoming more accessible to more people. So there's a tremendous amount of people interested and engaging in this space, and we want to provide them with the access to the knowledge and the finance and the physical resources that they need to do that, and the Innovation Showcase is part of that. Just to talk a little bit about who we're trying to work with, we've put together a team of judges and advisors, and these are the main ones up here, but very pleased to say that Ryan Vinyard, who we have on the line from Highway 1, will be one of the technical reviewers at the event in Washington, D.C. next week. And really, we're trying to get innovators access to best-in-class thought leaders. People know what they're doing with taking products to market and have had the opportunity to do that in a number of different settings. And it's that technical advice that we really feel that we can help and add value. So that's a little bit of context on the Innovation Showcase platform, which this webinar is brought to you by today. Just to say, if you want more information, please visit thisishardware.org. There's lots of information on there about the competition and then also about the participants for this year. The deadline's passed for this year, but if you have ideas that you would like to submit, we'll be running the competition again next year. So as I alluded to, we're really very lucky to have Ryan Vinyard with us from Highway 1, which is an incubator, hardware-focused incubator on the West Coast in San Francisco. And he can tell you a little bit more about their organization, but we asked Ryan to come and share his experience with us in terms of prototyping. You know, people are getting very interested in the process of taking products to market, and prototyping is obviously a key element of that. It's a very challenging thing to do correctly, and you know, with the technologies that are available out there, there's various different options and there's lots of different tools, but it doesn't take away from the need to really understand the process and do it in a diligent and systematic way. So Ryan, as I say, is the engineering lead from Highway 1. He's had tremendous experience taking products to market with numerous Fortune 500 brands. Before he was at Highway 1, which is a PCH initiative, he worked at various startups, specifically in the electric vehicle space, and then also with thermal systems. So I'll pass it over to Ryan, who's the main speaker for today. He's going to go through the topic of the day, which is 2D versus 3D versus 4D prototyping. As I say, if you have questions as we go through, please feel free to put them in the chat box, and we'll answer them as best as we can once Ryan's had the opportunity to take us through his presentation. So with that, over to you, Ryan, just to say thanks again for being with us, and you know, take it from here.
Great. Well, thank you so much, Paul, for that introduction and for coordinating this whole event. And thank you to the American Society of Mechanical Engineers for hosting it. It's been good for Highway 1 to be involved in this, and we're looking forward to being out there next week and seeing all the great teams and great projects. Yeah, so I appreciate everyone calling in as well. It's a good opportunity today just to talk about prototyping. It's earliest phase in mechanical engineering, and want to talk a little bit about, you know, some of the things I've seen, some of the things that work, some of the things that don't work. And really just, you know, iterative prototyping. How do we use rapid prototyping, early, quick, and dirty 2D methods to lower the risk, learn from users, and iterate. So quickly on my background, after school, I worked at a few startups around the Bay Area, like Paul said, focusing in on electric vehicles and power electronics. Glacier Bay and Motive are the ones I have there. I'm going to use a case study from Glacier Bay later on actually a trucking application. And then I've been with PCH for 3 years now, started at the PCH Lime Lab group. They do traditional product development consulting for bigger Fortune 500 brands. So that's where I started getting more exposure to manufacturing, spent some more time in China, saw mass production, and really saw how those transition points can hurt. And for the last 2 years, I've been at Highway 1 since we started. I'm the lead engineer here, helping startups make prototypes and, again, just lower risk, which is what prototyping is all about. So you're probably all wondering now, what do I even mean by 2D versus 3D versus 4D prototyping? So I wanted to walk through that a little bit just to kind of explain, what I mean by that and why I'm such a big fan of 2D prototyping, which is a lot of what I'm getting at in this lecture. So by 2D prototyping, I really just mean lower resolution prototyping. So a lot of this stuff really ends up in, quote unquote 3D, 2.5D, whatever you want to call it. But in general, what I'm really trying to show everyone here is the benefits of low resolution prototyping in terms of time, in terms of cost, but also really just in terms of what you're going to learn from it. So this one's a fun example. It's, prototypes of a keyboard. And what I like about these foam core prototypes is, you could hand this to a user without even knowing kind of what the end product is going to be, what the color is, what the application, and just get raw feedbacks, in this case about ergonomics. Does this even fit in your hand? Is this the right shape? Really bulk stuff. So, this is something I've seen when I was at startups and then advising startups at Highway 1, is sometimes people just don't take advantage of these early methods, and all of a sudden the more complicated prototypes are not as easy to learn from. To kind of step further, 3D prototyping is more traditional, so this is kind of an interesting one. This is just a 5-axis crazy CNC mill to make an impeller. So 3D prototyping is kind of the more traditional. Like Paul said, a lot of the equations in 3D prototyping have been changing recently with the increase in availability and lower cost of 3D printing in the early stages of additive manufacturing. So in general, this is traditionally what's been around more. So people jump to it pretty early. But I'm going to show you guys later how it can actually help to kind of keep your mind in 2D, show lower resolution prototypes to users and get that feedback. And by 4D prototyping, I'm really talking about videos in general. And a lot of what I see there is obviously been emphasized by the recent increase in crowdfunding. So the picture here is one of our Highway 1 startups, Poto. They raised $430,000 on Kickstarter. And I think that's, 4D prototyping is interesting because it adds a lot to the experience. You can ship someone a 3D prototype in the mail, you can have a meeting and show it to them in person, but without kind of adding a dimension to that, explaining what the prototype means, not only explaining what it is, how it was prototyped, but really, how does this change the experience? What's the context here? What can I really learn from a video? Or the other example would be an experiential prototype. And what I mean by that is, hey, if your client wants a hospital waiting room and not, a new defibrillator, you probably need to prototype a whole hospital waiting room and actually walk them through the experience to get that. So video and experiential prototypes are what I'm talking about with 4D. So to come back quickly to the Poto example, what I loved about that is the Poto product is basically a stick anywhere camera. So it's one of those things that's pretty easy to explain, but I think they did a great job in their Kickstarter video of explaining not only, hey, what's my 3D product, this camera I can stick anywhere, not only what do I do with it, mainly they're targeting the selfie market, but also just how does that change the whole experience? If I had this for a day in my life, how would that be different? How would I be taking pictures of my friends differently? Is it just faster? Is it better? Is it cheaper? So that's really the benefit I see of 4D prototyping. And part of why I'm emphasizing that a bit is you really only get one shot at this. So you can make lots and lots of 2D prototypes. They're cheap. They're easy. You can throw them away. I encourage teams to keep them because they'll end up in your museum someday when you're as big as Google. But in general, 4D prototype is typically a Kickstarter video or other crowdfunding video that launches you to the world. So you only get to do that once. So knowing that, I encourage teams to spend a lot more time in the 2D world. So to kind of flesh that out a bit, like I said, 2D, you can take a little bit more, end up in 3 dimensions a little bit, but really what I'm talking about is low resolution prototyping, stuff you can do quickly. Once I have it on the whiteboard, which I would still argue is a 2D prototype, how do I put that into foam core, into cardboard, into something I can laser cut into a physical form where I can start to show it to users, start to validate simplified mechanisms, and also start to learn a bit about materials and things like that. And 3D prototyping is, more traditional, like I said, and I think people jump to that pretty quickly these days, especially with the advent of 3D printers. They're great tools, but I would say that, 3D printer can take a day, which is, much faster than it used to take 2 weeks to outsource a CNC part. But even a day is longer than the hour that you could cut something out of foam core or laser cut and learn in 2D. And then, of course, like I said, 4D prototyping is really using a whole video to show the experience. And I emphasize crowdfunding, but this could also be a launch video. This could be something on your website. This could be something you should send to VCs or investors to walk them through a whole experience if you don't have the opportunity to show them in person. So just to flesh out 2D, 3D, 4D a little bit more. And to bring that back to mechanical engineering development, because we're here talking to the ASME, I wanted to walk through a few of the typical prototyping processes for 2D and 3D. Obviously, 4D is a little bit different. So whiteboard's the common one. Definitely encourage every team, don't try to sell something in 3D CAD or the 3D printer until you've done it on a whiteboard, and then brought that into foam core. So foam core, I'll show you a few foam core prototypes later. But what I really like about that and why I'm emphasizing that over something like cardboard is it's really easy to cheap out, get cardboard, get some duct tape, tape it together and see what you want. But that's pretty flimsy. So what I like about foam core, it's the kind of white two-sided foam board that you can get at most art supply stores. Think like science fair presentation. The little trifold things are always made out of foam core. And what's really nice about that is it's nice enough that you can show it to users, you can show it to people and they kind of know it's a prototype. It's not this ugly piece of cardboard that they're kind of commenting on, hey, why'd you use old cardboard? They understand it's a prototype, but they also understand it's early enough that it's a concept, right? So you can show it to them, get that raw feedback about your concept, and not be getting little detailed feedback about things like the radius on it, the color of it, little CMF features rather than the core features of the product. And then from there, obviously, encourage teams to stay in 2D for a little while. Again, a lot of times just because it's faster. So I see people 3D printing, rectilinear boxes, and it's, hey, if we put a dovetail joint on that, we could laser cut that in an hour and learn what you're going to spend 2 days to learn on the 3D printer. So, laser cutters are great, water jet if you've got sheet metal, and kind of moving up to that next level. And then, of course, 3D prototyping. 3D printing is the big one these days. CNC is the more traditional method, but it's also becoming more traditional for manufacturing because it's becoming a more scalable process. And then, of course, 3D foam. So this is more in the industrial design world than mechanical engineering world, but there's a lot you can learn in 3D with, some good foam and a hot wire cutter. So in general, just, think in blocks before you get to the details. So with that out there, I wanted to walk through a case study from a startup that I spent time at called Glacier Bay. So we were over in the East Bay, in the Bay Area, working on power electronics and clean tech space. So this was before Kickstarter, before a lot of the current hardware startups. For perspective, there was no Pebble, there was no Nest. We didn't even know it was hardware yet. We were still just mechanical engineers working on technology. So before a lot of kind of the hardware revolution of the last 4 or 5 years. So for context, the product I was working on there, Climate Cab was our primary product. Like I said, we were, emphasizing power electronics, and our secret sauce was controls. And where we ended up being able to implement that was in a truck air conditioning system. So we were, technically the product leader in an all-electric air conditioning system for trucks, which allowed them to run air conditioning at night for the sleeper cab without having to idle their engine. So it was a great technology, but the project that I got set on there was to redesign our evaporator. And without going into an entire HVAC lesson here, the important thing to know is just that the evaporator is basically the cooling unit of any HVAC system. So in this product, that was the forward-facing, more designed element of the product. So the evaporator was in the truck cab with the trucker. So that was basically how they saw the product, how they interfaced with it. Everything else was buried under the cab. So it was really important that we got better airflow, better profile on the wall, and overall a more elegant design with the part that our users were interfacing with. So knowing that our current evaporator wasn't really optimized, like we all should, we started with a brainstorm. So what you see here is kind of the captured thoughts of our brainstorm. After we had a few ideas on the wall, there's only so many ways you can put fans and heat exchangers together. So we started to kind of lump those into groups. So you kind of see here, idea A through H, where we categorized a lot of those. So that really helped us to get a lot of brains in the room. It's amazing how much you can get through in an hour with a whiteboard without even having to go to the shop. So we got all the ideas out there, and we were also able to down select quickly and say, well, hey, we love the impeller, but that's going to be way too thick. That's not going to meet the needs we have for the low profile on the wall, even if it increases the airflow. So were quickly able to make trade-offs that way before we even started prototyping. So the next slide I wanted to show is just how do you start with this simple. So like I said, we're trying to optimize airflow, get as much airflow as you can, but not have a big high-profile evaporator. So what you see here is, really a dead simple test bench. It looks more complicated than it needs to be because, one of our engineers was a master with a MIG welder, so we defaulted to MIG welding rather than some simpler stuff. What we were able to do here was set a frame, set distances between each thing, and basically iterate between the wall, the fans, and the heat exchanger. So we're able to quickly create a graph just to know, with the fans that are in the airflow range and price point we need, should the heat exchanger generally be 1 inch, half an inch, 2 inch, 5 inches from the fans. So we'll see some quick data later, but that allowed us to get an anchor to start the rest of the design from by just isolating this one problem and really just kind of leaving one dimension of iteration. So once we learned that, we moved into some more foam core. So, you see a lot of foam core in these pictures, some poster board as well. And basically what I was able to do was in a day create a test rig where I could iterate the angle of the fans to test what the best angle would be. So we already learned the distance, we can now learn the angle and start to optimize that way. So you see all the white parts here are foam core. In the image on the right, you can even see a little living hinge that you're able to build in a foam core. That's what I like about it too, is if you're creative, you can do circles and some more, 2.5D things, like I said. And a question I get a lot when I'm talking about this project is, well, why didn't you just do FEA? Why didn't you just do some analysis? Why didn't you just throw it into a CFD engine and see what the optimal was? And part of it's because there were so many variables that really wasn't the best way for us to start. So we definitely knew we needed to get there eventually. We're a startup, we're on a cash-strapped budget. It was a lot easier and cheaper for us at the time to throw an engineer at the problem myself and kind of prototype our way at least into knowing what we should be analyzing. So we're able to iterate rapidly, learn the distance, learn the angles, and then add more complexity. So the image you see here is kind of later in testing, based on the primary attack angle that we knew would work, started adding things like curvature, just adding more iteration. What we did here was iterate the width of the inlets there. So that's why you see all the kind of sealing gaskets and then weights on the top in order to quickly move the test bench, take another data point, and move on. And that's something I want to emphasize too here. It's just the data. So, this was a lot of quick and dirty prototypes, but we did a pretty good job of instrumenting what was important here. So basically we were able to instrument the back pressure on the pressure drop, which told us the fan performance, the current or power draw of the fan, because we were all operating off of batteries. It was pretty important to us. And then, of course, the airflow we were trying to optimize. And like most things in engineering, there's not, one perfect answer. But we really saw, you can kind of see on the graph on the right, we started seeing asymptote around 26 inches where, you get a little bit more performance at 34 inches, but not worth justifying growing the industrial design just for that little bit more airflow. So by adding some simple data to the system, we were able to learn from the quick and dirty 2D prototypes. And then after that, we added some more complexity. So the test rig you see on the left, the difference there is that took, 2 weeks of fab and then another week to build to get to that level, whereas the earlier test benches I could build by myself in a day. So what you see here is there's still some foam core in the middle, actually. Those curved sections allowed us to articulate quicker and iterate. But you also see some sheet metal parts. So because we found that good 45-degree angle, we got some sheet metal parts fab for that. And you even see some 3D printed parts in the back there. So you see some FDM parts on the back wall, granting the overall curvature. So what was interesting there is, that technology has grown so rapidly. This was 5-6 years ago at this point. So FDM parts took us an entire week and hundreds of dollars to obtain, whereas now there's been a big proliferation of that, and you can get, FDM or 3D printed parts much quicker. And then also, once you add that complexity, it's worth just getting more data. So you can probably see all the sensor wires hanging everywhere on the left picture. Added a bunch of thermistors. We added the HVAC circuit itself, which is what's on the bottom. So now we're not just optimizing airflow, we're optimizing it while the HVAC circuit is running to see if the condensation and other factors have an effect. Got out our thermal camera at that point. Obviously, since we had more thermal involved, we're able to kind of add more complexity to learn from more data sets. And so what we ended up at the end of that was, the basic forms we needed for our 3D design. So what was really great about that is we were able to give this to an industrial designer and say, hey, don't scorch the earth and, give me 30 concepts. It's got to be about this size, but, how do we make it more elegant? So just with some quick and dirty prototyping, learning a lot in 2D, we were able to lower the risk before we moved into 3D, spent more money, started manufacturing and started tooling. So just wanted to walk through that case study about, how I've learned a lot in 2D before moving to 3D. Because it's something we emphasize with the startups here at Highway 1 as well. So don't have a 4D example for that project because Kickstarter wasn't really there yet, and we were, a bigger startup that didn't really make sense for crowdfunding. But we did eventually make some videos to send out to truckers to be able to kind of share the experience with them and say, is this going to be better in the truck cab? In general, what we heard from them was, hey, it's got to be a lower profile, but is there anything else we're missing? So by really kind of using all the prototyping methods in series and iteratively prototyping, we were able to lower the risk that what we ended up building in 3D and spending more time on money on was the right thing to build. So just wanted to run through that and tell you guys about all the benefits of 2D prototyping. And with that, I'll turn it back to Paul for the Q&A. Thank you.
Excellent, Ryan. Thanks so much for that. It was really good to see you run through that example and then also to talk about the different stages and the kind of desire from people to go straight towards, especially in this world, straight towards the 3D printing when there's so much good work that you can do before then. So thank you for setting that scene and painting that picture. We're just waiting for questions to come in, so I'll start with a few if that's okay. Really interested to know, and I guess it's how long is a piece of string, but this particular example that you're talking us through, how many iterations of prototyping did you do, and how long was the process?
Good questions, Paul. So basically, the rhythm that we got into here, we basically had weekly standing meetings. So every week we would check in on the prototype status. We were trying to kind of learn quickly, do the quick and dirty. So basically, my cycle was basically day of prototyping, day of data present, and then kind of go to the weekly meeting and give the update to kind of get the larger team's buy-in, make sure my VP of engineering knew where we were going, and make sure that it still met the original scope of the project. So I would say we went through kind of 4 major prototype iterations in terms of kind of starting with, just the linear test bench, what distance makes sense, moving to the angular test bench, what angle is going to be ideal, and then really starting to add things like curvature where we iterated with. But what was really great for us is because we made flexibility in each of those test benches, I would say we had 4 primary test benches, but probably 100 different data points with 4 different metrics in each of those data points. So we were able to rapidly create, 400 data points in the real world we could learn from, rather than creating, 4 million CFD data points that we didn't really have context on because we were optimizing, a smaller thing in analysis tools. So, 4 major iterations, 400 data points to really learn from each one.
Awesome. This is going to be a tough question, but I'm going to go there anyway. What are the things that you see as the biggest challenges or the biggest mistakes people regularly make when they're doing their prototyping process?
So obviously for me, a lot of it, like I said, is jumping to 3D printers too early. Not learning from the whiteboard. And the benefit I see in a whiteboard is not because, hey, I can do things in 3 colors and, hey, I could just do that in pen. It's because it's a communication device, not as much a documentation device. You can get everyone in the room, everyone's looking at the same whiteboard, everyone's looking at the same sketch, and you can start to check assumptions and communicate amongst your team to say, hey, did you think we were going to be iterating angles, or were you thinking we were iterating linearly first? So, that's a mistake I see. But the other one I would say is just not putting prototypes in users' hands early enough. So if you're, afraid to put a 2D foam core prototype in a user's hand, you're just not taking that opportunity to learn as an entrepreneur. And it's a really hard process because they're going to give you brutal feedback. But honestly, the brutal feedback you can get from a 2D foam core prototype might help you understand and pivot your product earlier at a lower cost to your prototyping and team runway. So I think that the hesitation to show prototypes to users is a big one. There's kind of this feeling like, hey, it's got to be done before I show it to anyone. If it's got to be done before you show it to anyone, it'll never be done. So that's something, using low resolution prototyping methods, number one, is what I would encourage. And number two, showing those low resolution prototypes to users.
Yeah, I think that's an excellent point that you bring up, Ryan. And I think this is where the technical side goes with the business side. And I think as engineers, often people want it to be perfect before it goes out of the door. And that's actually, the worst thing you can do in terms of when you're in a startup, because obviously the feedback that you get from your users really helps you iterate and develop not only the product but also your business model. And it's just valuable intelligence that you can get back. So, I think that obviously with something like the Lean Business Canvas, people are encouraged to get out to potential customers and potential users as early as possible. And I think, from what I'm hearing you're saying about prototyping, if you take that similar approach, you can actually almost kill two birds with one stone by getting the prototyping momentum going and then also getting the business model momentum going.
Absolutely. And what I would add to that, Paul, is, to me, a prototype is fundamentally to learn, right? You shouldn't be making a prototype if you're not learning from it. Now, a lot of people just see that as learning about the prototyping method, right? Should I be foam coring? Should I be laser cutting? Should I be 3D printing? But I would argue that each prototype needs a thesis or hypothesis in that way. You should be knowing going into that, am I here to learn about the prototyping method, or am I here to create something clean with that prototyping method I can show to users and learn from the users? Or is it the investor side, learn if they're going to fund it or learn why they won't fund it? So that's what I'd like to add to that as well is, prototypes are there to learn.
Awesome. And you make a really good point about being very focused and going into each kind of testing situation with a very clear goal in mind rather than, trying to think you can learn too much from interactions. Be very specific about what you want to get out of each of the sort of user group interactions that you have. I have a quick question for you about Highway 1 and sort of the time frame and the process. I don't know, I think it'd be very useful for people on the line to hear a little bit about your model, your application procedure, the kind of support you guys give if we have people that are interested in getting some of this type of support or submitting, ideas to you guys as a hardware incubator.
Yeah, it's a great question, Paul. Thanks for asking. Our applications are open right now, so we're definitely actively looking for teams. But yeah, in general, Highway 1, we're a hardware accelerator, hardware incubator. There's lots of terms. We can call it whatever we want. But in general, we're here to help hardware startups grow. So we focus that on the prototype development, trying to make sure that prototypes are always getting closer to manufacturing. So our parent company, PCH, traditionally has done supply chain management and manufacturing logistics. So Highway 1 as an accelerator is trying to emphasize that strength and depth. So we take the teams to China for 10 days to give them exposure to mass production. We also bring over to the U.S. process engineers from China to go deeper on manufacturing and process questions. So in general, we have 9 staff members here. 5 of them are technical, 3 engineers, 1 designer, and our shop tech. So we're heavily focused on the engineering development side, making sure prototypes get closer to manufacturing. But we're also here to grow the startups as a whole. So we have kind of a business development track. We have a PR track. We're trying to make sure that you're meeting the right investors, making the right partnerships, doing the right PR to make sure that you can launch, whether that's for demo day or whether that's later. So we wrap up the whole program with a demo day at the end, bring in investors, bring in press, help people, craft their story to tell the world what they're doing, and help them launch. So it's a pretty intensive boot camp for 16 weeks. The teams need to relocate to San Francisco. We've got a full service office in Potrero Hill, machine shop on site, manual mill, manual lathe, CNC mill, pick and place machine, refill oven, everything you need to prototype something in a day. So that's kind of the overview. And then we seed $50,000 of funding to each team in exchange for 4 to 7% equity. So that's a bit of a Highway 1 program, and then PCH also has a follow-on program called PCH Access that's for later stage teams. So PCH Access is basically to help them ramp manufacturing itself. So Highway 1's here to get them from proof of concept prototype to fundable prototype, and that's what we've done with 45 teams so far through 4 cohorts.
Awesome. Thanks for that overview. Just a little bit of a kind of more personal question. You know, what gets you out of bed every morning in terms of the work that you're doing with a spring in your step? Is it working with the innovators? Is it looking at new technologies? You know, what's the things that really excite you with the things that you do day to day?
Yeah, great question, Paul. I mean, I guess the short answer would be solving problems. Like, I really like the opportunity. We have so many startups working on all these prototypes. You know, those are my favorite moments, whether that's in the lab with a prototype, whether that's on a whiteboard looking at their business model, you know, whether that's, you know, just counseling team dynamics, whatever comes up, it's many things. But the ability to kind of work on so many different startups, I like to describe it that I have the greatest job in the world because, you know, I still kind of work at a big company, but I get to work with 12 startups every day. So I get to wear many hats and be involved in all their projects. So the ability to help them with all that debug, the ability to help them solve real problems, but on so many different projects and so many different markets is really the diversity of problems that keeps me going every day. And then, like you mentioned, it is kind of just fun to see new technology. Like when we're interviewing applicants, I'll see products that are, you know, 1 to 4 years out from hitting the store shelves, and frankly, maybe never will hit the store shelf because it's a startup. So it kind of gives me an open eye into the future of hardware as well.
Excellent. We're all very jealous of you right now. It sounds like a tremendous role that balances the sort of technical side with the business side and the creativity as well. You know, the opportunity to be creative and entrepreneurial is something that I think many people strive for, and you know, getting that in an engineering environment is something that sometimes is tough. So it's you've got a lot of people who would wish they were in your shoes right now, but it's excellent to hear and learn from your experience. One last question, and you mentioned it a number of times in the prototyping, and it's as 4D prototyping and the video and the launch. And, you know, you said sometimes it's not to do with crowdfunding, but obviously crowdfunding has become such a essential tool almost in people getting customer feedback, people getting awareness of what they're trying to do. And, you know, because hardware takes significantly more capital than other types of startups, it's a really great way of getting some funds in the door. I don't know if you've got some examples or some suggestions that we could share of things that you've come across that have been good crowdfunding campaigns in the hardware space.
Yeah, it's a good question, Paul. I mean, I think it's an interesting landscape to me because, like I said, you know, even though I was doing this project at Glacier Bay 5 years ago, you know, Kickstarter maybe existed as a website, but that was 2 years before Pebble had been on there. No one ever heard of it. The business model didn't exist. And I think it's evolved even in those last 3 and 4 years a bit from kind of an organic, you know, tooling budget to really an orchestrated PR launch. And I think that's something that, you know, startups who aren't kind of in the Silicon Valley ecosystem or in the startup world still kind of see Kickstarter as just a soft launch to get out there. But that page is there forever. If your Kickstarter campaign fails, that's going to be on the internet for everyone knew. So I think that, you know, it takes a little bit more money and a little bit further prototypes and established relationships with manufacturers to have visibility on the back end to really have a strong orchestrated Kickstarter or crowdfunding launch. So, you know, like I said, I think the Poto team did a great job of using that. They chose Kickstarter because it's got a big community. You know, Indiegogo has a bit friendlier terms on the finance side, so we see a lot of people use them. But part of it's picking your crowdfunding site. So do you want to go with a big community? Do you want to go with, you know, something like CrowdTilt is pointed at the open source community? You know, pick something close to home. So first of all, picking the right platform. But secondly, like you said, using that platform to really tell your story. To talk to Poto again, it's, you can explain the product pretty simply. It's like, okay, the Stick Anywhere camera. Okay, great. Well, why would I use that? To take a selfie. Okay, great. How does having a Stick Anywhere camera that takes a selfie actually change my day? And I think that's where they did a great job in their video of explaining, well, hey, here's a day in the life once you have a Poto, and you're kind of freed from, putting your phone, tilted up on a rock to take your pictures. So I think that, a lot of teams have taken great advantage of that. Pebble was the first kind of one in the hardware space to go big on that. And I think, again, that's because they showed not just, hey, I'm going to get an e-paper screen on your wrist. It's what am I going to do with it? How is that going to change things? How am I going to add applications to that? How is that really going to change the experience in my daily life? So really bringing it to the user experience level to be able to explain that through a video.
Yeah, thank you. I think, when fads come along and people see the successful campaigns, it's very easy to think that happened by luck or overnight or didn't require a lot of effort. And I think, people are starting to realize now with crowdfunding that it's a significant investment. It's very complex to do right. And as you mentioned in your notes, you really do only have one chance to get it right. So it's almost sometimes quite a high-risk strategy as well.
Yep.
But I think it's, especially for hardware people, I think it's a really great way of getting customer feedback and a great way of getting awareness and, just getting some of the funds in there that aren't always available at some of the competitions or some of the incubators. I think we're just evolving, and this is why it's so great to have you guys involved at Highway 1, because I think you're really thought leaders in the hardware incubation space, and you're doing things in a way and systemizing it in a way that not many people are doing. So we love the work that you do, and we're happy to support it. And we hope there's a whole host more of organizations like yourself popping up, because I think not to be too cliched, but hardware is hard. And it's a whole different animal compared to the other startup areas of software and business model innovation. It really, the barriers and the valley of death is far bigger. So the hardware innovators need all the help they can get, and we're trying to play our part, and we're really grateful for you guys doing what you do.
Great, thank you, Paul.
Yeah, awesome. I think we'll wrap it up there. You've got Ryan's email on the line, so I'm sure he'd be happy to answer questions in the future. And check out Highway 1's website and their application process, because I think it's something that anyone who's interested in hardware and has a startup idea should definitely check out, because they've got a great program over there. One last thing to say before we drop off. This May 14th in Washington, D.C. at the District Architecture Center is where we're hosting the U.S. version of the Innovation Showcase. You can sign up for that online at thisishardware.org. If you want to see 10 great hardware innovations and you want to learn about what's going on, that would be a good place to start. So we would welcome you to come and participate with us there. Just before I wrap up, let me just say one last time a really big thank you to Ryan for joining us today. I think it was a very informative conversation and some great points on prototyping. I'm going to give the last word to Ryan in a moment, but what I took from what you said, Ryan, was prototype early, prototype often, and don't be afraid to get something in a physical form, and don't be wowed by technology. Get the nuts and bolts of things figured out in low resolution prototyping, and then move on from there. Well, over to you for the last word.
Yeah, exactly, Paul. So I think, entrepreneurs hear the phrase fail early and often quite often, and something you're going to start hearing more and more is prototype early and often. So, get your prototype into a 2D form, lowers the cost of getting it there, lowers the time, lowers the risk, but also show those prototypes to users. So don't be afraid to expose yourself as an entrepreneur, because the sooner you get stuff in people's hands, the sooner you'll learn what you should really be making. So, yeah, just wanted to thank Paul and ASME for the opportunity to talk here, and looking forward to the event next week. Thank you.
Excellent. Well, with that, it's a wrap. Thanks very much, everyone, for joining, and we hope that we've given you a little bit of inspiration to get out there and start making some prototypes.